So for this first part of the assignment, I have to locate frame number 8, and it's unencrypted 802.11 data frame. And in order to find this, we have to open frame 8 in the packet analyzer and expand the IEEE 802.11 tab kind of in the, it's like the left corner. And we have to find the source and destination MAC addresses. So as you can see, I'm opening the 802.11 tab right there in the left corner, and those packets, or not the packet, but the addresses for the MAC address, the destination address is 009096 BD 7735, and the source address is Gemtech Techno, and then just 001A733D673C, and that is for frame number 8. So in this case, the source address for the MAC address, it's used for identifying the sender, and the destination MAC address is used to identify the recipient of the message or just whatever data is being transferred. So layer 2 ensures that the reliable point-to-point communication in the local network by using these addresses. All right, the next task on the list is to just find the source and destination IP address. And the way to do this is go into the IPv4 section and find the source and destination addresses. And in our case, the source address for frame number 8 would be 192.168.151, and the destination address 192.168.152. And again, that's just in the Internet Protocol version 4 tab on the left corner. Now, what this does is just handle logical addressing and routing, which allows data to pass between different networks using IP addresses. Now, the source IP address and the destination IP address, within layer 3, they enable inter-network communication and routing beyond the local network. So that's what that does. Now, the next task that we were tasked to find was the source and destination TCP ports, which was in layer 4. And the way to find this is just in the Transmission Control Protocol tab, and it's also in the bottom left corner. And from there, you can see the source and destination port numbers. And what this basically does is just provide end-to-end connections and reliability for applications using ports to direct traffic to specific services. Mainly just HTTP, that's an example, and FTP. Now, in the case for frame number 8, the source port number is 20, and the destination port number is 1105, or just 1105. What these port numbers do, the source port and the destination port, they use layer 4, or within layer 4, they use ports to process just communication matching traffic just to the correct applications, so nothing gets mixed up. The next thing that we were tasked to locate was the unencrypted text data, which was in layer 7. And the way to locate this is also in the bottom left corner within the frame details. Just scroll down to see the data or the payload. If it's unencrypted, which in this case it is, it'll say ASC11. But yeah, I'll show you in a second. So in the case for frame number 8, it'll just say character encoding ASC11, or I guess II. But that just means the data is unencrypted. Now, what this means is just the application layer, or layer 7, it's responsible for interpreting and displaying the data to users, or serving it to applications such as like web pages or emails. And in this case, for layer 7, the unencrypted text data, ASC11, it just allows for the intended software, such as the browser or email clients, to process and display the data of the user, or the data to the user, but that's essentially what it does. Next, I was tasked with finding frame 136. You have to kind of scroll down for a little bit, but once you reach it, it's kind of easy to find everything because it's pretty much in the same position as the other one. To locate the source and destination MAC address, it's the same with frame number 8. You just go under IoT, or not IoT, IEEE 802.11, and you'll be able to find the MAC addresses under source and destination. Now, for the case of frame 136, the destination address was Gemtech Techno. 001A733D673C, and the source address was ASCII compute underscore BD, or 009096 BD 7735, and that was all in the same spot as frame number 8. So now essentially what this does is just even in like encrypted frames, the MAC address, they're visible and they're really critical for network delivery at the data link. Again, in frame 136, I was also tasked with finding the location of the upper layer information and also why it's missing. And to find this, you have to go into like the headers such as IP or TCP. However, in the case for this, I actually couldn't find those tabs because there's only 3 tabs. But yeah, for the explanation, it's just that the IP addresses and TCP ports, they're inside the encrypted payload, so the analyzer can't display them. This is why they don't appear. And in this encrypted frame, the upper layer details like IPs and ports are concealed within the encrypted payload. They're not visible without decryption, which prevents eavesdroppers from viewing sensitive information. So for this last kind of task that we had to do for frame 136, tasked with finding the encrypted or scrambled data. And where that is, it's just in the data tab in the not the far left, but in the left-hand corner in the bottom. And the data is just gonna show up as random kind of gibberish or non-readable data types. And basically what this is just, it's encrypted data appearing as like binary or hexadecimal gibberish. And this only shows up so that authorized recipients with the correct keys are allowed to decrypt it and understand what that message was, which just keeps the data confidential, which is pretty good for privacy. So yeah.